Here we have a SAT math problem. Okay, let's go to the question. In the right triangle above, the value of sin C is 0.6 and the length of BC is 20. What is the length of AD? We have to find the length of this line segment AD over here. Okay, let me consider the value of sin C given over here. That is 0.6. Let me write the stuff over here. Sin C equals to 0.6. And we can write this value 0.6 as a fraction as 6 over 10. Okay, now we can simplify this one. That is 2 goes into 6 3 times, 2 goes into 10 5 times. Then I'm getting 3 over 5. Okay, according to Seccato, the formula for sine is opposite side divided by hypotenuse. Let me write out here. Okay, here the number corresponding to opposite side is 3 and the number corresponding to hypotenuse is 5. And we have to consider the interior angle measure at the vertex C because here we have sin C. Okay, now in this right triangle ABC, consider the interior angle measure at the vertex C. Okay, considering this interior angle measure at the vertex C, the side which is opposite to the interior angle measure vertex C is called opposite side, and the side which is opposite to the right angle is called hypotenuse, and the remaining side over here AC is called adjacent side. Okay, we know that the number corresponding to opposite side is 3. That is considering the interior angle measure of the vertex C. So 3 is the opposite side. Let me write 3 over here. And 5 is the hypotenuse. Let me write 5 over here. And clearly it's a 3, 4, 5 right triangle because the length of the hypotenuse is 5. In the remaining two legs AB and AC, the length of one of the legs is 3 and the length of the other leg AC has to be 4. So clearly it's a 3, 4, 5 right triangle. Okay, from these numbers 3, 4 and 5, if I want to get the actual lengths of the three sides of the triangle, I have to multiply all these three numbers by the same non-zero positive number, say x. That is, when I multiply this one by x, I'm getting 3x. 3x is the actual length of the side AB. And when I multiply this 4 by x, I'm getting 4x. 4x is the actual length of AC. And when I multiply this 5 by x, 5x is the actual length of BC. But already we know the length of BC. What is it? It's 20. So we got that 5x as the length of BC, but the length of BC is already given in the question, that is 20. So this 5x and 20 represent the same stuff, so we can equate them. Okay, now let's divide both sides by 5 to solve for x. When I do so, this 5 will cancel out. Then I'm getting x equals to 20 divided by 5 is 4. Okay, I got the value of x. Now when I plug in x over here, and I'll be getting 4 times 4. 4 times 4 is 16. So 16 is the length of AC. When I plug in 4 for x over here, I'm getting 3 times 4. 3 times 4 is 12. So 12 is the length of AB. Okay, here when I plug in x equals to 4 over here, I'm getting 20. That is the given length. Okay, now what I'm going to do is I'm going to find the area of this triangle, right triangle ABC. Okay, for that there is a formula. First, let me write the stuff over here. Area of triangle ABC equals to, the formula is 1 over 2 times base times height. Okay, here since it's a right triangle, so here we have a right angle, then this leg can be considered as a base and this leg can be considered as height. Okay, 1 over 2 times the base of the triangle, just now we got it, that is 16. We can plug in 16 for base, and the height of the triangle, we got it, that is 12. We can plug in 12 for h. 2 goes into 2 1 times and 2 goes into 16 8 times. Okay, when I multiply this 1 and 8, I'm getting 1 times 8 is 8. 8 times 12 is 96. Okay, now I got the area of the triangle ABC, that is 96 square units. Okay, we can get the area of the same triangle ABC in the other way. That is, actually this AD is an altitude of the triangle, that is height, because it has been drawn from the vertex A to one of the sides of the triangle. This is an height of the triangle. When we consider this AD as the height of the triangle, then BC will become the base of the triangle. So now I'm going to consider this AD as height and BC as base. And again, I find the area of the same triangle ABC. Let me write it. So area of triangle ABC equals to 1 over 2 times base. Base here is BC. Let me write it. And height is AD. Let me write it. Okay, already we have the area of triangle ABC. Here we got it, that is 96. We can plug in this 96 for this area of triangle ABC. So then we get 1 over 2 times. We know the length of BC, it's given in the question itself, that is 20 times AD. 2 goes into 2 1 times and 2 goes into 20 10 times. Then I'm getting 96 equals to 1 times 10 is 10 times AD. Our aim is to find the length of the line segment AD. So for that we have to divide both sides by 10. When I do so, this 10 will cancel out. When I divide this 96 by 10, I'm getting 9.6. On the right side we have AD. Okay, I got the length of the line segment AD, that is 9.6 units. We find this 9.6 in answer choice C. The correct answer choice for this question is C.